Welcome back, everyone. I am so incredibly excited to have you here for Module 4 of our Explainer series. Today, we're taking some pretty advanced, bleeding-edge AI concepts, and we're going to translate the whole shebang into plain English. If you've been hanging out with us for a while, you know we absolutely love a good analogy, so today we're heavily relying on our AI librarian metaphor. We are going to explore the mechanics of something called RAG, and I promise you by the end of this explainer, you're going to understand exactly how enterprise-grade AI actually thinks and fetches information. Let's get into it.
So, I want you to just think about this question for a second. How do we actually teach an AI to find a literal needle in a massive digital haystack, right? Because when you ask an AI a question about your company's data, you definitely do not want it acting like some confused intern who's just wildly flipping through file cabinets. Or worse, an intern who just spilled coffee all over your Q3 reports. No way. You want it to act like a master librarian, someone who knows exactly where every single piece of information is, how it connects to everything else, and how to summarize it perfectly for you.
Okay, let's dive straight into this. We've got a really logical journey for you today. Here is our agenda. 1. We'll look at the RAG pipeline. 2. Clean ingestion and chunking. 3. Metadata and hybrid search. 4. Making AI confident. And 5. We'll wrap up with the enterprise AI future.
All right, Section 1, the RAG pipeline. This is really the foundation of AI search.
Now, if you've used any major AI chatbot recently, I bet you've experienced this exact thing. You ask what seems like a simple question, maybe it's about math or a specific document, and the AI fires back with this incredibly articulate, super confident answer that is just flat out 100% wrong. It might totally misinterpret a formula, or it grabs the completely wrong context. So why does a supposedly smart AI do this?
Well, the industry term for this is a hallucination. Basically, a hallucination happens when an AI model generates false, misleading, or just totally illogical info and presents it to you as absolute fact. You see, an AI on its own is really just an isolated brain. If you ask it a question and it doesn't have a library of real, grounded facts to actually look up, it just guesses. It predicts what the answer should sound like without actually knowing the truth at all. To fix this, we use a system called RAG. That stands for Retrieval Augmented Generation. RAG is our AI librarian, and here's the chronological pipeline of how it works. First up is ingestion. This is where we literally stock the library shelves with your actual documents. Second is chunking. Imagine the librarian going through every single book and highlighting specific paragraphs so they're super easy to scan later on. Third is retrieval. When you ask a question, the librarian goes straight to the exact right highlighted paragraph. And finally, fourth is generation. The AI reads that specific paragraph and writes a perfect, fact-based answer just for you. No guessing allowed whatsoever.
Moving right along to Section 2, clean ingestion and chunking. This is all about preparing your AI's data.
There is a golden rule in data science, and you've probably heard it. Garbage in, garbage out. A massive mistake people make is skipping straight to the shiny new AI models while completely ignoring their underlying data quality. The quality of your AI's final answer is entirely bounded by how cleanly you ingest the original documents. Think about it. If you feed the AI raw HTML code from a website, complete with navigation bars, cookie banners, and random ad scripts, the AI is going to embed all that junk right alongside the actual valuable content, and you will get terrible, confused answers. You absolutely have to extract clean text first.
Okay, so once we actually have beautifully clean text, we have to chunk it. We have to break those massive, unwieldy documents down into bite-sized pieces for the AI to process. And there are two main ways we do this. Strategy A is heading-based chunking. This is brilliant because it splits the text based on actual topic headings, preserving the semantic meaning, meaning it keeps related ideas grouped together perfectly. Then there's strategy B, which is fixed-size chunking. This is kind of the brute force method, where you just slice the document every, say, 500 words, using a bit of overlap so you don't accidentally cut a vital sentence right in half. Generally speaking, you'd use strategy A for nice, well-structured reports, and strategy B for messy, raw notes.
Now, what's really interesting about the data here is that more isn't always better. If you look at the dark blue bar on the left, there's a method called DenseX that created nearly 33,000 chunks. It wildly over-segmented the data into these tiny, fragmented pieces. But then look over to the right. Methods like GraphSeg or LumberChunker only created around 2,500 to 3,700 chunks. And research shows that those methods, the ones with fewer but highly coherent, structurally sound chunks, actually result in far better AI retrieval. It is entirely about quality over quantity. Over-segmenting just confuses our poor librarian with way too many tiny, disconnected sticky notes.
All right, Section 3, metadata and hybrid search. Let's talk about how we actually find the right info.
Imagine asking your system for the company vacation policy. The AI needs to know exactly which policy to look at, right? We do this using metadata. You can think of it as the Dewey Decimal System for our AI library. Now, we can use pre-filtering, where the AI sorts through the HR folders before it even begins searching for the word vacation. Or we can use post-filtering, where it just grabs every single document in the whole company that mentions vacations and then throws away the ones that aren't specifically tagged as HR. Honestly, pre-filtering is the way to go because it guarantees we are only looking at the active 2026 policy and not some outdated 2019 version.
So once we're actually in the right folder, how do we search? We basically have two distinct styles. First is vector search. This is finding data by vibe or semantic meaning. If you search for cheap flights, vector search is smart enough to find documents talking about budget airfare, even though those exact words don't match. Pretty cool, right? However, vector search is notoriously terrible at finding specific serial numbers, and that is exactly where keyword search comes in. It finds exact lexical matches. Think of searching for SKU-44819 or a highly specific IT error code like ERR_con_RST. Because both of those search types have pretty massive blind spots, the ultimate solution is something called hybrid search. Hybrid search runs a traditional keyword search and a semantic vector search side by side at the exact same time, and then beautifully fuses the best results together into one unified list. You don't have to choose between rich context and precise accuracy anymore. It is literally the equivalent of asking your master librarian to find a book where you know the exact title, but hey, you also want them to suggest other books that share the same general topic. You get the absolute best of both worlds. Moving into Section 4, Making AI Confident. This is how we stop those pesky hallucinations.
So the crucial point we need to talk about is the single embedding problem. You see, Vanilla RAG relies on just one single embedding model to retrieve information. It's kind of like relying on one single human expert to answer every single question in your entire company. A model that excels at summarizing text might be absolutely terrible at complex mathematical reasoning. It might capture the semantic meaning just fine, but totally drop the ball on logical structures and financial formulas. This single embedding problem leads to a really static, unreliable workflow that just breaks down under pressure.
Now take a really good look at this comparison. We have Vanilla RAG at the top and our new method, Confident RAG, in the middle. Up top, Vanilla RAG asks one single embedding model to find the chunks, passes them to the language model, and spits out an answer. If that one model grabs the wrong chunk, well, the final answer is totally wrong. But look down at the Confident RAG workflow. Here, we actually ask a panel of multiple embedding models to retrieve data. We run the generation process multiple times in parallel, creating several different potential answers. Then, and this is the absolute magic part, we measure the statistical confidence level of each generated output based on token probability. Notice the confidence scores there on the right. One answer scores a 0.52, another a 0.88, but one peaks at 0.94. Confident RAG selects that highest confidence answer as the final output. It is literally consulting a panel of experts and going with the one who is most statistically certain of their math.
Just to summarize the sheer power of this method, Confident RAG completely transforms your system. By consulting this expert panel of models and using advanced mathematical metrics like distributional perplexity and self-certainty, which in plain English just means the AI double-checks its own math to see how consistent its logic is before opening its mouth, this system automatically filters out low-confidence hallucinations before you ever even see them. The research data shows that this method delivers roughly a 10% average accuracy improvement over just asking a vanilla language model on its own. For complex reasoning and math, it literally makes the AI trustworthy enough to actually rely on in a serious enterprise setting.
And that brings us to Section 5, the Enterprise AI Future. Let's look at the real-world impact. The ultimate point of this entire pipeline really comes down to one number, 80%. That's right. When you combine clean ingestion, smart chunking, hybrid search, and confident agentic workflows, you create a true RAG-powered knowledge agent. Case studies show that when this type of AI librarian indexes your company's documents, wikis, and databases, it can reduce employee search time by a staggering 80%. That is a huge deal. No more digging through nested folders or reading outdated policies. The answer is just there, synthesized, perfectly accurate, and fully cited.
So, we've translated the cutting-edge mechanics of retrieval-augmented generation into plain English today. You now know exactly how the AI librarian stocks the shelves, how it searches, and how it mathematically verifies its own answers to avoid hallucinations entirely. The technology is here, folks, and it is accessible today. So I'll leave you with this provocative thought. Now that you actually understand the mechanics under the hood,
How will you implement this trusted, highly confident AI librarian in your own business to unlock your team's true potential? Thank you so much for joining me for Module 4. Keep learning, and I will see you in the next explainer.